All right, it's 5 o'clock. We start the first lecture of the new academic year on time. So welcome to everyone. This is our first lecture, public lecture of the new year, as we said, organized by the 21st Century China Center. My name is Li Huang. I am the executive director of the center. It's my great pleasure to welcome today's speaker, Kyle Chen. Kyle is a postdoc researcher in the sociology department at Princeton University, an adjunct researcher at the RAND Corporation. His academic work focuses on China's technological development and industrial policy, from railways to EVs to clean tech to AI and robotics, hot topics at the center of the US-China policy discussions. In addition to his academic research, Kyle contributes actively to policy discussions on these topics. He has testified before the US-China Economy and Security Review Commission. He writes very popular, widely read newsletter called High Capacity, putting a plug in there for you, which reaches thousands of readers interested in China's tech and industrial policies. So if you would like to subscribe to that, I'm sure you can find it online. And today's event will look like this. Kyle will give a presentation, probably around 30 minutes. Then maybe I'll come up with a couple of questions at the first round as you guys prepare with your comments or questions. And then the remaining time, about 20 plus minutes, will be devoted to audience interaction. Today's event is a hybrid event. So there are a couple of housekeeping notes. One is that this event is being recorded. Second is that online attendees can submit questions using the Q&A box. We have Harry Doche monitor the questions, and we'll consolidate them and for the speaker during the Q&A period. So please join me in giving a warm welcome to Kyle. Welcome.
Okay, thank you for that very kind introduction, and thank you for having me here today. I'm really excited to speak with all of you. That's fine. Okay. All right, so today I'll be talking about China's technological development, industrial policy, state efforts to try to accelerate China's progress in a whole range of areas: AI, robotics, electric vehicles, batteries, clean tech. The list goes on and on. And I thought first it'd be fun just kind of make this whole topic more vivid for you guys to play a little video of a Unity humanoid robot. So I don't know about you guys, but my social media feed is full of these kind of videos on a near daily basis. And I think on one hand, obviously they're marketing, but on the other hand, I do think that they start to capture some of the advancements that we're seeing coming out of China in an area that is fairly new, humanoid robots. And actually, this one in particular, this fake news, you can buy it in Walmart, I guess, for $21,000. I didn't hit buy on this one, but if anyone wants to, it seems like a pretty good deal. But also, I mean, and a kind of related point is that this robot has become sort of a hardware platform for a lot of labs in the United States, trying to do robotics and AI. And it's not just robots, right? So after DeepSeek, we had a whole slew of world-class AI models coming out of China. Alibaba, Moonshots, Kimi, um, uh, Tencent. So both big tech companies and startups, and almost all of them are open source. You also have the rise of Chinese electric vehicles by companies like BYD, um, Geely, Neo, and these EVs have now have started to take a lot of market share, not just within China, where they really started to push out a lot of the legacy incumbent automakers, but also market share globally, including in Europe, especially in Southeast Asia, Latin America, and not quite here in the United States. And there are certain tariff-related reasons for that. But this is sort of another ongoing parallel development. You can look at pretty much the entire clean tech supply chain, whether you're talking about solar, batteries, wind. You can drill down to any one of those industries and look at, say, for batteries or EV batteries, the anodes, cathodes, the materials that go into them that are refined and processed, the lithium separators. These are now dominated by Chinese producers. And you can see just in terms of the sheer scale of production, that especially for so-called clean tech goods or green goods, China's scale dwarfs a lot of the rest of the world. And in fact, a lot of Chinese exports have enabled a lot of other countries to accelerate their transitions away from fossil fuels. So how has China been able to do this? I haven't even talked about some other areas like quantum fusion, sort of more emerging technologies. Maybe I'll touch on those in a few minutes later. But I want to highlight a few reasons, a few drivers behind China's ability to make such rapid progress technologically, and also to scale up in areas of advanced manufacturing over time. And the first area I would point to is actually learning from the rest of the world. This is really key to understanding how China did not just reinvent the wheel from scratch, but instead built on technology, manufacturing know-how, and skills, supply chain management from other players. One example of this is what I originally focused my dissertation on a while back, was high-speed rail, where China not only has built the largest high-speed rail system, but it's built with these partnerships originally, these joint ventures between Chinese train makers and foreign train makers. And the idea here was that each of these train makers would have a slice of a very lucrative, booming Chinese high-speed rail market. And in return, they would build trains in China with Chinese partners, and through the process, share technology, share manufacturing knowledge, and train a new generation of Chinese engineers and technicians in how to make high-speed trains and the systems that go that make them run. And so you can see here, right, that especially in the early days, you even had sort of like a very direct sort of application of designs. And you can see this in other sectors too, like the automotive industry, where some of the there's some great research done on how Chinese auto companies that partnered with Japanese automakers ended up focusing more on energy efficient engines versus Chinese automakers that partnered with German ones like Volkswagen, which tended to produce sort of more powerful German style engines, as one example. Another example is Tesla's Shanghai Gigafactory. So this not only had this famous catfish effect of stimulating China's EV industry and also making EVs cool in China. That's not a small thing, but also actually helping to co-develop new manufacturing techniques that have now become something more like the industry standard. And one example of that is the so-called gigapress that was jointly developed between Tesla and a Chinese-owned company named Idra that's actually originally based in Italy. And they were to create these giant casting machines that would press aluminum in single pieces. So you could have a whole chunk of a car produced in a single piece that minimized labor costs, that sped up the whole process, that reduced the number of parts that you had to produce. And also later on, it helps to iterate new designs and new models more quickly. And this became something that Tesla very famously pioneered, but also ended up diffusing to the rest of to many other Chinese EV makers. So where they also bought similar machines. Some of them also buy LK Group, which was the parent company, and also some other local Chinese equipment makers, and employ this technique. And this is one of the many reasons why you get lower costs, you get faster production times for Chinese EV makers. And this is how you spread beyond China and to other automakers outside. But here's an example of Xiaomi gigacasting machine employing similar technology. So the point here is that it was really crucial for China to catch up, and in some areas, need to overtake some of their foreign counterparts by learning from foreign firms, foreign researchers, and engaging in these partnerships. So another huge factor is the role of local government. I think that sometimes too much focus is placed on a splashy central government plan like Made in China 2025. And there are reasons for that, and it does make sense. But I think what's underemphasized is the fact that in many cases, it's really the local governments that are the engine driving a lot of this production, building the new factories, providing the state support, providing the kinds of economic incentives to make this all happen. And in many cases, you would have, say, a signal from the top, whether it's a speech or a national AI plus action plan. And you will see this replicated in many cases at the local government level. Different municipalities, different provincial governments might come up with their own version that actually might even be more fleshed out than the national version, because they know that this is a signal from the top saying that these are priority areas, that this is a direction that the country should be investing in. And so I mentioned up here some images from a recent summit back in February where Xi Jinping met with a whole bunch of tech leaders and brought them together, including the heads of Huawei and BYD and CATL, and tried to signal support for the private sector, especially in driving tech innovation in China. And so, take it for what it's worth, right? There's still a debate about the role of support for the private sector, and especially given the fact that some of these CEOs up here, one in particular, had just a few years prior been part of a big tech crackdown and had been sort of exiled for a while from China. So there's sort of mixed messaging, but in general, this important role of the central signal and then the interpretation then from the local governments is a really crucial part of this process. What do local governments do in particular? Well, they can do a whole range of things. So this is actually from a piece a while ago looking at the iPhone factory built by Foxconn in Zhengzhou, and the incentives that Zhengzhou offered, including subsidized land, help with farm land, help with tax incentives for building the factory, even helping with recruitment and training of workers. And there was even a special airport that could transport products quickly, and that it in and of itself was sort of a special export zone. And so all these incentives together, as well as sort of cutting through red tape, helping with obtaining licenses and permits, dealing with environmental reviews, these are all ways, both financial and non-financial, by which local governments can try to support the local industry. And then sort of seen at a kind of a meso view. So I would focus on the macro central government, that maybe is sort of the more micro local government. When you look in between the local governments, this is really crucial. You get competition and experimentation, right? So this is really crucial where you may have multiple municipalities, provinces offering, almost sort of a bidding war or incentives to try to attract new EV factories, say, and offering sweeteners like economic support. You also might have programs where different cities, different jurisdictions try to use different uh, policy ideas to boost demand or production. For example, for EVs, there's the famous 10 cities, 1,000 vehicles program where it turned out to be more than 10 cities, but different cities try to mix of local government procurement efforts to say buy electric buses. They offer incentives for building EV chargers, especially in public areas. They offer consumer subsidies or tax credits, and they also, really crucially, in some cities, especially the large ones like Shanghai, Beijing, they had a special sort of license plate control regime where normally to reduce congestion and pollution, they put a cap on the number of license plates that were issued with an exemption for electric vehicles. And what that ended up doing is that was sort of like a really nice, in a way, like a tax break for people who bought EVs, incentivizing them to be able to bypass this license plate system, which otherwise was very, very expensive. And then another aspect that I would really emphasize is the adaptability. I think there might be a misconception that industrial policy is about really, really large scale plans and executing them consistently for years, if not decades at a time. And what's consistent is the goal. That is the goal of, say, being a major automaker or a major EV producer. But what's not consistent are the policy tools and strategies. Those might evolve over time. And actually, when we look at the automotive industry, we see some major pivots, right? There was a time when China tried to use joint ventures to bring in foreign automakers for traditional automotive manufacturing. And that had mixed success. On one hand, it did actually boost China's overall capacity for automotive production and also helped to develop a robust traditional automotive supply chain domestically. But it didn't produce the kinds of world class global brands that I think China had aspired to. There was not, until recently, a Chinese equivalent of Toyota or GM. Um, but that changed, of course, with a switch to electric vehicles or so-called new energy vehicles. And this is, a strategy that in some ways bypassed some of the bottlenecks of a previous era. The frustrations about these JVs not producing enough tech transfer, especially for core technology around combustion engines. And now here you have a whole new route that you could take, again, building off of some other types of foreign investment, like that Tesla plant, but also building off of other existing supply chain strengths in China that I'll come back to in a second. And even within EVs, within new energy vehicles, China employed a mixed approach. It wasn't just about battery EVs, it was also about hybrids and hydrogen fuel cells. So this ended up paying off pretty well because at various points in time, it wasn't clear when, which of these technologies would be the one that would win out. Japan made a really big bet on hybrids and also on hydrogen fuel cells, and that seemed to have been mistaken now in retrospect, possibly, because the cost of EV batteries has declined so dramatically. And there's also a question about the battery chemistries themselves. So China tried to pursue a whole range of different battery chemistries, not just nickel manganese cobalt, which is what, say, an older generation of Teslas use, but also lithium iron phosphate batteries, which are cheaper, safer, more reliable, have more life cycles. And even next generation technology like sodium ion and now solid state batteries. And some of this is very interesting because some of this is very private sector driven. Companies like CATL making very, very large multi-billion dollar investments over years in the R&D. But this also, again, there's a dimension of state support here. For example, forming a consortium of industry participants, including CATL and UID, to jointly collaborate and work together on solid state battery research. There are reasons for keeping that industry competitive. There are also maybe some military applications for these sorts of technologies. And then this, I can't emphasize enough, it's maybe not as exciting a topic for some people as like a gigacasting machine, but China's sheer investment in fundamental scientific research and talent, the investment in universities over time has been really crucial, underpinning all this sort of industrial progress. So I think this is something that marks China a little bit differently than other countries, other developing countries that have tried these industrial policies in the past. To have a scientific foundation to be able to take a technology transfer partnership and actually incorporate it and sort of understand the core technology is crucial. So this is, for example, the recent Nature Index of institutions ranked by scientific output. And there are reasons why huge presence ranking more than other rankings that are say citation count, which can be perhaps gained. But I think this has to be a pretty strong signal that 8 of the top 10 institutions for research, and this is across a whole range of different fields from physics to biology, are Chinese. And 42 of the top 100 are Chinese institutions, universities, or Chinese Academy of Sciences. And you can quibble with exactly where the rankings are and whether Harvard is higher than whatever. But I think overall the message is that the research that's being done, the scientific work being done at Chinese universities in many areas is really at the global frontier. Also, the researchers themselves, many of them are globally competitive. So if we look at AI, for example, the fact that we have now half a dozen world-class AI models coming out of China did not come out of nowhere. So those who've been following the space for a while will know that if you look at the major AI conferences like NeurIPS, they're full of Chinese researchers and Chinese institutions. And this is from some data from 2022 looking at one particular NeurIPS conference and who showed up, whose papers were accepted. And if you look at the undergrad institutions of where those researchers went to college, half of them roughly went to Chinese universities. And that's where I think you might have heard on like CNBC, Jensen Huang, the CEO of NVIDIA, saying like half of AI talent is Chinese. I think this is sort of what he's referencing here. And if you look at where they end up, actually a lot of them end up moving from China to the US. But many also stay in China and work at Chinese AI labs. And this is a very confusing chart, but if you recall, recently Meta had this whole push to build a super intelligence team where they're offering absolutely ridiculous compensation packages, on the order of like 10, $100 million, even I think $1 billion. And they try to recruit the very, very best. So this is like the creme de la creme of AI talent in the world, and offer them like sky high packages. And it turned out, if you actually drill down to who these people were and where they were educated, many of them were Chinese educated as undergrad in Chinese institutions. Tsinghua gets a lot of representation here. So, okay, and if you look at patent data as well, you can see that this correlates well with China's rise in areas like solar and wind. So all that's just to say that there's a broader scientific foundation that all this is built on top of. And so it's not just about having these joint ventures or having these sort of clever policy experimentations at the surface level, that there's a sort of deeper set of factors underneath all that. And then another area I would like to point out is, what I call like industry spillovers. The fact that China's not just pursuing industrial policy in one sector or in a handful of sectors, but in a whole range of sectors that have cross-cutting effects. So an example I like to give is wind installation turbine vessels, which China has the largest shipbuilding industry in the world, and it helps to be able to build these special ships that can install offshore wind turbines, and that turns out to be a key bottleneck later on for other countries trying to do offshore wind. Similar for electric vehicles, how are you going to ship them and export them? Well, it helps to be able to also build the specialized vehicle carrying cargo ships that China can also build and also leverage being the world's largest steel and aluminum producer. So those are also key inputs into the paradoxically heavy industry. China's very, very large heavy industry base feeds into its clean energy capabilities. And just for the sake of time, I'll try to skip through some of these things. But this is sort of like a summary of some of these overlapping industries, how it's not just EVs alone or batteries or AI, but how they all sort of are interlocking and build on each other. And that there are literally certain companies that kind of lie at the intersection of some of these things, like Xiaomi pivoting from smartphones to EVs, or DJI, which makes not only drones, but sensors that now go into robots, like Unitrix robot that I showed you at the beginning, or Huawei at the center, where they kind of do everything: AI, cloud, 5G. They are in the EV world as well as autonomous driving. Um, and so when you scratch the surface for these new emerging technologies like humanoid robots, you see a lot of the supply chain is already there, because all of that supply chain came from, say, the EV industry, or had overlaps with the smartphone industry in terms of sensors, actuators, electric drives, batteries, and chips. Another example of sort of an emerging technology is the so-called low altitude economy with flying taxis. And again, this builds off of a lot of combination of basically drone technology plus EV technology. There are a lot of problems with China's use of industrial policy, especially at the scale that it tries to deploy that. One problem is that you get market bubbles. So my favorite example here is Evergrande. Remember the real estate company that went bust? Well, they at one point had an EV unit that was apparently, and it's almost unbelievable, but according to Bloomberg, was valued over $80 billion. So Evergrande having EV unit should be a red flag for anyone. There are examples of, say, semiconductor investment funds that were wasted, that went into sort of fraudulent companies that ran away with money, and the founders, were never really held to account. There are problems with involution daydream and this sort of vicious competition or overcompetition, a race to the bottom where profits are secondary to building greater capacity. And part of this is also coming back to the local government competition, where local governments want to signal to the center that they are jumping in line with priorities, that they are trying to pull in and invest in new, say, production capacity for yet more solar panels, for example. So this is the problem that ends up resulting in overcapacity and also international backlash from countries like the United States and Europe, but also across the global south, Brazil, Indonesia, Mexico, where they're putting up tariffs, worried about a flood of Chinese exports that are seeking to get away from this sort of vicious domestic competition. What's one solution? One solution is the outbound expansion of Chinese manufacturing investment. That is, building factories abroad, whether it's solar panels in Vietnam or BYD electric cars in Brazil, Hungary, Turkey, Thailand, or it's batteries in Germany or Spain or Morocco. Now we are seeing, I think, an explosion of outbound investment from China in manufacturing in particular. And this is sort of different from previous trends where Chinese companies tried to buy technology essentially from especially developed countries. This is more about creating a sort of a new set of global supply chains centered around China, but with some of the core technology, and I think some of the export controls come into this, still retained within China, but then some of the perhaps lower value assembly work being done in other countries, partly to evade tariffs and get around trade restrictions. And the question is, of course, will this create jobs on the ground in these countries? Will there be technology transfer, and will there be economic value created, or will they just be sort of like assembly shells? And that's obviously not what countries are hoping for. They're hoping for sort of the real stuff here. And I call this kind of industrial diplomacy, where it's not random where these companies are investing. And I argue that Beijing is trying to steer investment into friendly countries and away from countries that are deemed not so friendly. Yeah, I'll skip this one. This is a BYD car carrying vessel exporting EVs from Thailand to Europe. These are some examples of areas where Chinese manufacturing investment has been sort of kind of steered towards, and then some countries where they've sort of been steered away from. And then lastly, sorry, kind of blazing through some of these slides here. But China's now trying to apply some of the similar industrial policy tools towards areas you might not think are traditionally areas where you could do industrial policy. And one of those is AI. So this is part of a RAND report that I helped lead, where we're looking at China's state support across the entire AI tech stack. And we find that essentially at every single layer, you can find different kinds of programs, different kinds of state support, whether it's at the level of chips and servers or data centers, models and applications, especially for so-called hard tech applications like robotics, physical AI, smart cities. The types of tools, policy tools that Beijing has deployed really vary. They can include government guidance funds, investment funds. They can include industrial parks, often at the local level. There are many very well-known local government backed AI labs, like Shanghai AI Lab, Zhejiang has one, Beijing has a few. Often they are ways where universities also collaborate with industry participants and help to set new standards, create new evaluation benchmarks. And another area where China's been trying to apply state support is on compute capacity. So there's a very large scale infrastructure program right now called the Eastern Data Western Computing Program. And essentially this tries to build data centers in Western provinces that are rich in renewable resources and leverage that energy to power these data centers so that some of the compute where most of the customer demand money on the wealthier eastern provinces can be sent over to the west for sort of like training models and then sent back. On one hand, this seems like a classic like Chinese infrastructure story, right? But with data centers instead of high-speed rail. On the other hand, it's tricky because AI is a very fast-moving technology with frequent paradigm shifts, unlike say high-speed rail technology. And so what happened is actually this is already starting to run into some issues in their adjustment program because in the age of inference time compute and the rise of reasoning models, latency matters a lot. In other words, you don't want your data centers processing and doing inference far from the actual customer or user. You want those to be actually fairly close together. So there's some kind of reconfiguring of some of these resources. Also along the way, some of these data centers turn out to be very poorly made. There are a lot of issues with local governments who just have no idea how to build a data center. It's not like building a road. It's a very complex technical process. In many cases, they want to satisfy certain thresholds to get the government incentives. So there's definitely a lot of waste and even outright fraud in this whole process. But the last thing I'll just mention is a key motivator behind China's industrial policy, and a factor that's been growing even stronger more recently is export controls and resilience and developing so-called autonomous and controllable technology that is no longer being exposed to say US export controls on semiconductor chips. So you have efforts by, say, Huawei, Cameron, actually a whole host of Chinese tech companies themselves have their own AI chips in development, trying to replace the video chips, which have been export controlled by the United States. At a deeper level, the semiconductor manufacturing equipment itself has also, in many cases, been controlled. So crucial equipment and materials like lithography machines, etching, deposition, photoresist, a lot of these are starting to be limited to China, and China is trying to basically recreate almost the entire semiconductor supply chain domestically as a result. And it remains to be seen whether this is ultimately something they can pull off. Some things like lithography machines are notoriously difficult and themselves are comprised of thousands of components with very complex supply chains. But one thing that has been interesting to note, and this is from a foreign policy piece that I helped co-author just a few months ago, is that these issues are not just about hardware. There's a hardware software ecosystem that is fundamental to driving some of these new emerging technologies. It's not just about how fast your chips are, what the specs are on compute throughput or memory bandwidth. It's also about whether you have the software libraries, in the case of CUDA, whether you have the specialized kernels for processing or for training algorithms and running models and doing inference. And so, in the case of Huawei's competition and efforts to substitute for NVIDIA chips, it's not just that Huawei specs, seem to be for the 910 C seem to be coming close to NVIDIA's H100 on paper. What matters is also the fact that a lot of Chinese AI developers grew up with CUDA. They grew up with the NVIDIA platform, and they grew up writing code optimized for that kind of platform using the very deep software libraries that were built on top of that. And that's what Huawei is using, for example. And so more recently, though, there's been an effort by Chinese AI developers, including DeepSeek, to at least sort of signal that they are willing to participate and work with the hardware makers to complete this sort of feedback loop that we've seen actually in other areas where China has been more successful with industrial policy. That is, you have the upstream and downstream components of the supply chain working together to try to do this iterative process of improving the hardware, developing the software ecosystem, and creating a alternative platform to the American platforms. And in many cases, these platforms are open source deliberately to make it easier to coordinate, make it easier to contribute, and make it easier to build up a robust ecosystem that's separate from the United States. Again, it remains to be seen whether this will be successful in the long run. But I would argue that although China has long pursued self-reliance in certain key technologies, I would argue that I think that export controls have really spurred China's efforts and have brought in players that previously were not as heavily active, like Huawei itself in semiconductor chips. And so now going forward, as we enter move from the world of trade wars to sort of like broader economic and tech warfare, a question will be, to what extent can the US or China overcome these sorts of exposures, choke points, supply chain bottlenecks, and to what extent can each country develop sort of its own robust, resilient alternative to sort of being at the mercy of the other in terms of geopolitical tools. So that's all I have, and reach out to me. This is my information. So thank you.
Thank you, Kyle. Maybe as you guys think about the lecture and come up with questions, let me ask you a couple of questions. So one is industrial policy firms, private firms, the state sector, because the way that we think about China and China's development, and especially the role of industrial policy. So the question is always, why did not that happen in the state sector? Right? If there's one sector that's sort of the target of the industrial policy, that's the implementer of state policy, that would be the large enterprises under state control. Instead, all these tech firms that you talked about were dominated by private entrepreneurs, engineers, and investors. How do you explain that? How do you explain that the industrial policy that's being touted as a success succeeded in one realm but not in another, especially in the realm where it's intended to happen?
Yeah, so I would argue that it's quite a messy story in terms of state dominated versus more private sector. So one complicating example is the high-speed rail program. So that is actually all state dominated. Virtually all the players involved in construction, infrastructure development, the train makers themselves, the operator, China Railway Corporation, they are all state owned. And there, China was able to successfully create competition among some of these state actors. So, for example, for the contractors that actually develop the infrastructure, that actually build the viaducts and the tracks and do the tunneling, there were actually a mixture of different state-owned subsidiaries of some of the big parent companies that competed for contracts. And so in that way, they could kind of create a quasi-market like setup, have it still be ultimately state control, but try to introduce some element of competition and innovation in that process.